When we have two sets of data, X and Y here, then it's often useful to know how well correlated they are. Does the increase in one produce an increase in the other? The first thing to do when looking at such data is to plot a scatter diagram, and we do that as follows. We highlight the data, X and Y. We go to Insert and Scatter, and we can choose the top left, and then we see a picture showing that in general there was a positive relationship. As X increases, so does Y. It doesn't always happen. There's a couple of examples where X increases but Y decreases. Another one here. But on the whole, the trend is upwards, and we talk about positive correlation. What we now want to do is to try to give a numerical measure of this correlation, and we do that using a correlation coefficient. And there are various versions of this, but the one that's most commonly used is called the Pearson product moment correlation coefficient. And we can work this out using one of the formulae in here. Under formulas, we go to more functions, and we want statistical because we're doing statistics, and we drag down here to Pearson, click on this. Now what we have to do here is put the data in. Array 1 is the X data, which starts at cell A2, and we can then do a colon and go to the last part of the data, and we can see there the numbers coming up. And for array 2 we want the Y data, so again we go to the first number, B2, colon, and then the last number. And we can already see that the product moment correlation coefficient has appeared, 0.86, etc. And if we OK, then that will pop out just there. That's a measure of how well correlated the X and Y variables are. If they were perfectly correlated, we'd get +1 as our correlation coefficient. If there was no correlation, we'd get 0. And if there was perfect inverse or negative correlation, we'd get -1. 0.86 shows that there is good correlation. It's quite near to +1.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.